Hello, welcome to ATAR exam preparation course. Today we're going to solve this question 18 of QCAA External Assessment Paper 2021, Paper 1, question 18. So this is a simple, it's a complex familiar question. So topic is a differential equation. So let's have a look at the question. So we give the differential equation with the two variables. One is the I. So what's I? I is the current of the electricity. And the time is using T in seconds and resistance. So we got so I and the T is the variable, R, V, and K are the constants. So you can see those are the constants. So don't forget T is greater than equal to 0. So that's a few things that we know is that when the electricity, no current of the electric circuit initially. So what's that means initially? So the I initially was when the time equal to 0 is 0. So that's a given. So we need to determine, we need to prove, show means to prove that the size of the current, so that means the I has to be greater than, never greater than, so it means less than V divided by R. So that's my goal to achieve. All right, so let's start prove that. So first step, we need to sort out this equation. So we got K derivative current with respect to time. So that's the initial differential equation. I'm going to move things around a little bit. So I'm going to move the I, so this is I, move to the right-hand side, become that. So what I'll do is I'm going to take some common factor. I'm going to take a V out. Sorry, I'm going to take a R out. So it becomes V divided by R minus I. So you can see I'll take a R as a common factor. Then I'm going to move the K to the right-hand side. So it become R divided by K, because they are constant. So this is the process of isolating the variables. So now I'm going to shift to this, the I with the current. So we move to the left-hand side. So I'm going to put a dI divided by V of R minus I equal to R over K dt. So I'll move dt to the right-hand side. You can see I'll separate two variables, one on the left and t on the right. So I'm going to integrate it to find a relationship between, so we need to find a relationship between I and the t. So I'm going to integrate it both sides. On the left-hand side, I'm going to do 1 over V over R I. The I on the right-hand side, I'm going to do integration with respect to time. So then do left-hand side becomes, the logarithm. So this is but it has to be negative because here's got a negative sign here. So therefore, I'm going to do negative log absolute value V over R minus I equal to right hand side is R over KT plus C. So we're going to decide what a C is. So because we know when the current equal to, when a T equal to 0, current is 0. Initial current is 0. So I'm going to substitute into the equation so we can get the, so that's a 0. So become left hand side, and then right hand side becomes C. So C is this. Now because R and the V and R are all positive, so therefore C is, you don't need an absolute value because those two values are positives. So C eventually will be negative log V over R. All right, we're going to substitute. So therefore my relationship, so be left-hand side become log V over R minus I. On the right-hand side is negative R over K because you multiply. Then plus C. C is a negative. Negative, negative become plus. All right, that's my relationship. So if you want to undo the relationship, you can use in the, so this case, we can decide the reason we want to, so our aiming for to prove the currency is less than V over R. So therefore, if you look at on the right-hand side, we know the log because log log function, we know log function when y equal to log x, the x must be greater than 0. So that's the logarithm function. So the x has to be greater than 0. So therefore, the V over R minus I have to be greater than 0. So therefore, I'm solving this by moving I to the right, become greater than I. So therefore, I must be less than V over R. So that's it. That's to solve the, so this is the aim. We have achieved this particular goal. So we need to prove this. So because of that equation here. So therefore, we prove that's the case. So we have solved this question. It's a complex, familiar question. Thank you for watching. If you liked the video, please give us thumbs up. And don't forget, subscribe channel so you can get the latest video. I'll see you next time. Bye.